All right, this video is going to talk about what we call slope. Now, what we want to do is come up with a nice pattern to help us graphing linear equations. And one of the really nice parts about linear lines, notice the red line that's on the graph here. Notice it makes a nice straight line. We can actually define that straight line or know that it's a straight line because it rises and runs in the same way. And that's one easy way to define slope. Now, the technical definition is the rate of a vertical change. So notice here, to get from this point down here, right, where I started the blue line, to this point up here where the green line is touching, notice that the rise, right, we were at -2 in the y coordinates. We went up to +1 in the y coordinates. So the rise is about 3 units. And the run, as we say, or the difference in the x coordinates, right, the horizontal change, the run is about 6 units. We've got -3 all the way up to +3 here, right, if we counted that along the x-axis. So the slope is basically a way to relate those two things. Again, it's the vertical change between 2 points on the line and divided by the horizontal change, or basically the rate, right, or the ratio of vertical change to horizontal change. The rise, 3 units, to run, 6 units. And if we divide those two things, we could actually reduce, right? 3 over 6 would be the same thing as 1/2. And you'll notice, if we actually go back to our line, that actually brings up an easy topic. Rather than going 6 units to the right, what if we had only gone 2 units to the right and then 1 unit up, right? Notice rise, right, of 1 unit, run of 2 units. So notice it's just a slightly smaller triangle, but you'll also notice that if I take that ratio and I move it anywhere along my line, right, that ratio stays the same, whether I'm from -1 to +1 in the x coordinates, or we go way up here, right, to the upper part of our line, all along that line, right, we've got that same ratio going on. Again, we could do the same thing with the 3 and the 6, right, from this point down here or all the way up top. Again, every point on that line, right, is related to every other point by a slope of 1/2. So when we talk about finding slope, that's one way to do it, is actually graph out 2 points, right, graph out the points, and just count out, right, rise. We always do the rise or the y coordinates essentially, right, the vertical divided by the x coordinates, divided by the run, rise over run. Now, if you actually know the points on the line, such as the 3 points we have over here, there is a mathematical method to this, right? The change in y is really the difference between two y coordinates, right? If you want to find the distance between two y coordinates, or the distance on just a straight line, right? Think of like a number line. We just subtract those two coordinates. Same thing goes for the horizontal. If we wanted to find the distance from left to right, we would just subtract those two x coordinates, right? So rather than counting out the coordinates, which would hopefully save us some time having to not have to graph all the time, we could just figure out what's the run and what's the rise, right, between these points. So if we want to go from B to A, right, if I want to go from point B to point A, one thing you want to realize is typically we want to take the second coordinate minus the first one, right? Think of it, if you want to find the distance between 0 and 10, well, that's not -10 units, right? That's not 0 minus 10. 10 minus 0 gives you 10 units, right? So again, if we think about that order on there, we'll go ahead and call it M. Again, that's typically going to be the letter we use for slope is M. And we'll just kind of use that, and you'll see why. It'll be very familiar to you after a while. But now let's go ahead and take our y coordinates. So again, I'm going to take the y coordinate from point A, right? So I'm going from B to A. So I'm going to subtract A, so 7, minus the B y coordinate, right? 3 over. Then I'm going to do the same thing. I'm going to take the 5 from the A coordinate. Notice y2 over here and x2. Again, they're coming from the same point. That little sub number isn't a number that we need to worry about that much. It's just telling you both of those coordinates, right, both x and y came from the same coordinate, the second coordinate, right, sub 2 there. Whereas both of these coordinates, right, y1 and x1, well, because they're point number 1, they'll come from the same coordinate. So very simply, if 3 came from that B coordinate, well, so does 2, right? That's the X coordinate. And remember, you're subtracting, right? y2 minus y1 over x2 minus x1. That's our shortcut formula, again, to find the slope. We're finding the ratio, right, fraction there, between the rise, which for us would have been 4 units, right, to get from 3 to 7, over the run. 5 minus 2 would be 3, or basically, remember that the distance from 2 to 5, right, left to right, okay, left to right here, would have been 3 units. And we figure out that our line has a slope of 4. If we want to find from B to C, so notice that next problem down here in the lower left, well, let's just do the same thing. Let's go ahead and subtract, and I'm going to do it real quickly there. We're going to take B minus C, which means C comes second, right? Which means it's going to come first in our formula, right? Sort of a first shall be last kind of a thing, right? So we've got -1, -1. So again, -1 for the y coordinate over -1 for the x coordinate. We're subtracting point B. So again, y on the top, so 3 on the top, x on the bottom. Rise over run, y's over x's. -1 minus 3 is -4, -1 minus 2 is -3. But notice, negative numbers divided, we still get a slope of 4/3. Okay? Again, the ratio of, right, think rate, we've got a fraction going on, ratio of the y's to the x's. Let's go ahead and try that a couple of times on the next screen here. So first of all, let's write down our shortcut formula. Don't forget that m equals y2 minus y1 over x2 minus x1. Pause the video now and go ahead and try finding the slope for the 2 points in the red box and the 2 points in the blue box, and let's see if we don't get the same answer. All right, well, hopefully you've started the video back up here because obviously you're hearing me. Let's go ahead and find these slopes, right? So what we're going to do, again, is take these 2 coordinate points, right? Here's what they would look like on our graph, right, on our line. And actually, technically, they should have an arrow on the upper left as well here. But there's what our line would look like. But let's see what that slope would look like and see if it doesn't match up with the line. Again, we're going to take m equals y2. So I'm going to go with that -3 over there, the y coordinate from the second point, minus y1 over x2 minus x1. And notice again, the zeros both came from the same coordinate point. The 3's both came from the same coordinate point. -3 minus 0 is -3. 3 minus 0 would be 3. And our slope comes out to -1. Or if you want to think of it, again, that's sort of like -1 over 1, right? The better answer is just the most simplified. But if we think of our ratio, well, let's go over to our graph real quick here. From the origin, if I went down 1 and right 1, I end up right back on my line, don't I? And again, that same idea really would work anywhere along my line, right? Anywhere along here, 1 point to 1 point. I'm going down 1 unit, right 1 unit, down 1 unit, right 1 unit. Or if you think of it, I could go left and up, right? Left 1 unit, up 1 unit. As long as we've got that negative slope going on, we're in good shape there. Which reminds me also, I can tell this is a negative slope because every negative slope, right, is going to fall on my graph. It's going to fall as we go from left to right. We're falling, or we're going downwards on our graph, right? Positive x to negative y. For every 1 unit we went to the right, right, the run, we went -1 unit downwards. Let's try that blue point, or these blue line over here at the right. So again, the same idea. Let's go ahead and say m equals, again, we've got our formula down there, y2, which would have been 4, minus y1, right, the y coordinate from the first point, over x2 minus x1. Now notice x1 here is -2. So remember, if we're subtracting a -2, right, it's as good as saying +2. So 4 minus 2 would have been 2, but 3 plus 2 should be 5, and we get a slope of 2/5. Well, let's go ahead and graph those points, and notice what happens. We have a rise. Get those arrows on there again. I never want to forget those arrows. We have a rise of 2 units. So if I go from this point here up 2 units, and then from that same spot to the right 5 units, rise of 2, run of 5, definitely makes sense as far as the slope goes for this blue line. Notice also, again, this was a positive 2/5, which makes me believe that my slope or my line should rise this time, which makes sense. It does. From left to right, we're definitely going up and to the right. Or, again, if we tacked on a couple of negatives, remember kind of like the last problem, if this was -2 and -5, wouldn't that still be 2/5, right? Negative and negative would have made a positive 2/5. In fact, if we had done our points backwards, what if we had said 2 and -2 were the same point, right? And they came from that point A, we'll call it, right? Well, how about to get to B, then we have to subtract off 4 being the y coordinate, 3 being the x coordinate. We're subtracting both times. Well, hey, that's -2, right, over -5. But again, that's still positive 2/5. It's still going to rise from left to right, right? Or for every 2 units up, we went 5 units right. For every 2 units down, we went 5 units left, right? Negative, negative still makes a positive slope. I hope that helps you finding slope. Feel free to watch the second video. This is just the first of 2 videos. The second one will talk a little bit more about some special slopes as well as applications of the slope formula, a couple of different ways to use it. So good luck and have a great day.